So in this lecture, I will explain regulation curve of a single phase transformer. In the previous lecture, so we derived what is the percentage voltage regulation of a single phase transformer for leading power factor and lagging power factor. And I2 R02 cos phi2. So plus or minus I2 X02 sin phi2 divided by E2 multiplied with 100. So I2 R02 by E2 into cos phi2 plus or minus I2 X02 by E2 sin phi2 and multiplied with 100. See, the I2 R02 is a voltage drop. The units of this one is volts and the E2 units is also volts. I2 X02 is the drop. This is a reactance drop. The units are volts and the E2 units also volts. Voltage by voltage, it has unitless quantity. So we can write it as a per unit resistance. The current which is multiplied with resistance, that's why it is called as a per unit resistance. You should remember like this. The base value is EMF only. Plus or minus per unit reactance sin phi2 into 100. We know that plus for lagging power factor and minus is for leading power factor. And if you multiply this 100, now this is percentage R cos phi2 plus or minus percentage X into sin phi2. So per unit resistance multiplied with 100, that is a percentage R, and this one is percentage X. Now we should draw the curve. So at unity power factor, if power factor is equal to 1, percentage voltage regulation is percentage R into 1 plus or minus percentage X. That means sin 0 value, the phi2 value is 0 degrees, sin 0 value is 0, then percentage R only. So it has some magnitude. That magnitude is, what is this value is called the percentage R. When these two drops are added, then only it will be maximum. So lagging power factor, at lagging power factor, maximum voltage regulation will be takes place. Maximum voltage regulation takes place because both were added. At leading power factor, so these two are subtracted, percentage R cos phi2 minus percentage X sin phi2. So at one of the power factor, if both are equal, then the percentage voltage regulation will be 0. So this is for the lagging power factor, and left side is for leading power factor, and it will be increases like this, and after that decreases. And for a leading power factor, it will be 0 at one of the power factor, and it will follows the curve like this, and this value is 1 and 0.8, 0.8, 0.6, 0.4 and 0.2, and 0 lagging power factor, same 0.8, 0.6, 0.4, 0.2 and 0 leading power factor. This is called the percentage voltage regulation, and this is a percentage voltage regulation is maximum. And at leading power factor, 0 voltage regulation takes place. 0 voltage regulation takes place. So if you observe this curve, the curve will be like this. This is called the regulation curve. And for lagging power factor, these two are added. For leading power factor, these two will be subtracted. So the maximum efficiency will be takes place at lagging power factor of the load. So percentage voltage regulation formula is I2 R02 cos phi2. So So plus or minus I2 x naught 2 sine phi 2, and plus is for lagging power factor, and we are getting percentage r cos phi 2 plus or minus percentage x sine phi 2. I want to get the maximum efficiency, maximum voltage regulation of a single phase transformer at lagging power factor, and the percentage r cos phi 2 plus percentage x sin phi 2. So this is a percentage voltage regulation, and differentiate this equation with respect to power factor angle, and with respect to power factor angle and made equal to 0. This is percentage r, differentiation of power factor angle cos phi 2 is now it will become minus sin phi 2 plus percentage x cos phi 2 is equal to 0. So from this, sin phi 2 by cos phi 2 is equal to percentage x divided by percentage r, that should be equal to x naught 2 divided by r naught 2. This is tan phi 2. So if you draw the equivalent circuit with respect to secondary, this is r naught 2, x naught 2, and this one is induced EMF, and the terminal voltage is V2, and the current which is flowing through this one is I2. E2 is equal to V2 plus I2 into Z02, and here you can find the cos theta is equal to, so here I got one triangle theta, and the base is R02, opponent is X02, and this one is Z02. Cos theta is equal to R02 divided by Z02. R02 divided by Z02, and tan theta is equal to X02 divided by R02. So what you are getting, tan phi 2 is equal to X02 divided by R02. Equate these two, then I am getting tan phi 2 is equal to tan theta. From this I can write it as phi 2 is equal to theta, where phi 2 is the secondary power factor angle, and theta is the internal impedance of the angle. Theta is the internal impedance angle. If phi 2 is equal to theta, the maximum voltage regulation will takes place. And the next one is condition for zero voltage regulation. So before that, we can write a X bar ratio of the, say suppose if it is a RL load, this is RL and XL of the load, the X by R ratio of the load should be equal to X by R ratio of the internal impedance, then maximum voltage regulation takes place. The zero voltage regulation will takes place at leading power factor. So at leading power factor only zero voltage regulation will takes place. Why? Because if one of the power factor and percentage drop, resistance drop should be equal to percentage reactance drop, this one with multiplying with power factor and sin phi 2. If this term, first term and second term both are equal, then only it will be 0, and percentage r cos phi 2 is equal to percentage x sin phi 2, and here tan phi 2 is equal to percentage r divided by percentage x, that is R02 by X02. We can write it as 1 by X02 by R02. What is X02 by R02? is 1 by tan theta is equal to cot theta, and we can write it as tan of 90 minus theta, and phi 2 is equal to 90 minus theta, and phi 2 plus theta is equal to 5 by 2 degrees. Then zero voltage regulation of single phase transformer takes place at this condition. So this is the condition for maximum voltage regulation and zero voltage regulation. And at power factor unity, if you observe percentage R, and at unity power factor, what you have observed, at unity power factor, percentage voltage regulation is equal to percentage R, that should be equal to full load copper loss, percentage full load copper loss. So full load copper loss divided by volt ampere rating of transformer multiplied with 100, then I am getting the percentage full load copper loss, and that should be equal to percentage R. So we know that I2 R02 by E2 is called the per unit resistance, and percentage resistance is I2 R02 by E2 into 100. So multiply with I2 and divided with I2. What is I2 square R02 is full load copper loss divided by kVA rating of transformer multiplied with 100. Then this is called the percentage full load copper loss. In some of the problems, he is indirectly mentioned the percentage resistance instead of giving the full load copper loss. And in reactance is also percentage reactance is also given. And if a percentage full load copper loss is given, you can assume that that is called the percentage resistance. So in this lecture, I will solve the most important and repeated problems in an university's examinations on voltage regulation of a single phase transformer. So coming to the first problem, a 250 by 125 volts 5 kVA transformer has a primary resistance of 0.2 and reactance of 0.75. As primary resistance is 0.2 and leakage reactance is 0.75 ohms, and secondary resistance R2 is equal to 0.05 ohms, and the reactance X2 is equal to 0.2 ohms. The primary induced EMF is E1 is equal to 250, E2 is equal to 125, and S value should be equal to 5 kVA. Determine its regulation while supplying full load on 0.8 leading power factor. So he is asking at 0.8 leading power factor, what is percentage voltage regulation. So the percentage voltage regulation formula from the previous lecture, I2 R02 cos phi 2 plus or minus I2 X02 sin phi 2 divided by E2 into 100. We know the power factor cos phi 2 is equal to 0.8 leading. He is asking at leading power factor. That's why there is no plus. We are having only minus. R0 to find out the R0 value, R2 plus K square times of R1, where K is equal to E2 divided by E1. And what is E2? E2 is 125 and E1 is 250. 125 divided by 250 is equal to 1 by 2. The K value is 0.5 and R1 is 0.2 as 0.5 whole square into 0.2. The R2 value is 0.05. So by using calc, you will get the answer is 0.1 ohms. Similarly, you can find out the total leakage reactance when referred to secondary x2 plus k square times of x1. What is the x2 value? X2 value is 0.2. 0.2 plus 0.5 whole square into what is the x1 value? The x1 value is 0.75. x1 value is 0.75. So now I got the answer is 0.3875 ohms. We know the kVA of a transformer. That kVA of transformer is 5 kVA. S is equal to 5 into 10 to the power of 3 VA. If you want to find out the secondary current, volt ampere divided by voltage, then you will get the current value. So 5 into 10 to the power of 3 divided by secondary induced EMF, that is 125. So finally I got it as full load current is 40 amperes. Then substitute the values in percentage voltage regulation formula. 40 into and R02 is 0.1, cos phi 2 is 0.8 minus 40 into x02 is 0.3875 into 0.6. So if cos phi 2 is 0.8, remember sin phi 2 value is 0.6. If cos phi 2 is 0.6, sin phi 2 is 0.8. So if you have a doubt, check in your calc. Divided by E2, that E2 is 125 into 100. So for a voltage regulation I am getting as minus 4.88. So finally is 4.88. So E2 minus V2 divided by E2 into 100 is equal to minus 4.88 percentage. We know that the secondary induced EMF is 125 volts, and E2 minus V2, what is the formula? I2 into R02 cos phi 2 minus X02 into sin phi 2. This is a drop. What is E2 is 125 minus V2, I2 is 40, R0 is 0.1 into 0.8 minus 0.3875 is X02 into sin phi 2 is 0.6. So from this V2, this drop is 125. So 125 minus means plus 6.1. This entire value is minus 6.1. So if it is goes to left side and V2 is goes to right side, 125 plus 6.1, that should be equal to 131.1 volts. You can observe the E2 value is 125 volts and V2 value is 131.1. This is possible for leading power factor only. In this, E2 is less than V2. That's why the percentage voltage regulation I am getting as a minus value or negative value. So this is a most important problem and repeated problem in all the universities. The problem is on voltage regulation on single phase transformer. So coming to the second problem, a 230 by 460 volts transformer has a primary resistance of 0.2 and the reactance of 0.5, and the corresponding values of secondary are 0.75 and 1.8. So here the primary induced EMF is 230 volts and the secondary induced EMF is 460 volts, and the primary resistance R1 is equal to 0.2 ohms and the reactance is 0.5 ohms, and now R2 is 0.75 ohms and the x2 value is 1.8 ohms. Find the secondary terminal voltage. Is asking V2 when supplying 10 amperes. That means the load current is 10 amperes at 0.8 power factor. S cos phi 2 is equal to 0.8. So power factor lagging. So first of all, you should write the formula. Percentage voltage regulation for a lagging power factor is I2 R02 cos phi 2 plus I2 X02 sin phi 2 divided by E2. The R02 is equal to R2 plus K square times of R1, and from this we can calculate the transformation ratio where K is equal to E2 by E1, and 230 by 460 means it is a step up transformer. 460 by 230, the K value is now 2. So now R2 is 0.75 plus 2 whole square into R1 is 0.2. So 0.75 plus 4 into 0.2 is 0.8. The value which I am getting is 1.55 ohms. And similarly, you can calculate x02 is equal to x2 plus k square times of x1. What is x2? What is the x2 value? The x2 value is 1.8 plus 2 whole square into 0.75. So 4 into 0.75. So finally I got it as 3.8 ohms. So 3.8 ohms. And then finally you can substitute here. So I2 value is 10 into 1.55 into power factor is 0.8 plus 10 into this is 3.8 into 0.6 divided by E2 is 460. Then I will get the percentage voltage regulation. So if you calculate this, then finally I got it as 7.65 percentage. He is asking a terminal voltage. So E2 minus V2 is equal to I2 R02 cos phi 2 plus I2 X02 sin phi 2. I2 is 10, R02 is, what is R02? R02 is 1.55. R02 is 1.55 into 0.8 plus 10 into the X02 value is 3.8 into 0.6. So then I am getting the drop is 35.2 volts. We know that E2 is 460 is minus V2 is equal to 35.2. Then V2 is equal to 460 minus 35.2. Finally I got the answer 424.8 volts. Coming to the next problem, calculate the regulation of a transformer in which the ohmic loss is 1% of the output and the reactance drop is 4% of the voltage. Ohmic loss, that means full load copper loss, percentage full load copper loss is equal to 1%. So as we have seen in the derivation, that should be equal to percentage R, and percentage X is equal to 4%. Then you can calculate the voltage regulation for 0.8 lagging power factor. Percentage voltage regulation is equal to percentage R cos phi plus percentage X sin phi. Plus is for lagging power factor. So substitute here 1 into 0.8 plus 4 into 0.6 2.4 plus 0.8, that should be equal to 3.2 percentage. And the second is for unity power factor. Second is for unity power factor. Percentage voltage regulation is equal to percentage R. The cos phi value is 1. So into 1 plus percentage x into, if cos phi is 1, sin phi is 0, that should be equal to percentage R. So that is 1% only. And the third bit is 0.8 leading power factor. So now the percentage voltage regulation is equal to percentage R cos phi minus percentage x sin phi. So R is 1 into 0.8 minus percentage reactance is 4 into 0.6. So 0.8 minus 2.4, that should be equal to minus 1.6 percentage. So this is for 0.8 leading power factor. And this problem is very, very important, and this problem is repeated in so many times, and this is a somewhat twisty problem, and this problem is appeared in one of the GATE examination also.